recording. Before we would go into new stuff in exploratory factor analysis, I would like only to make a brief recap that we discussed about exploratory factor analysis as a technique that can help us to take quite big set of original variables that should be ideally continuous, or let's call it cardinal, and we would like to replace this big set of variables by small amount of new variables that are somewhere behind our observed variables. And these new variables that we try, we would call it as extract from our data, are called factors. And that's why this technique, at least in exploratory style, is called exploratory factor analysis. We know also from previous discussion that there is also alternative technique for factor analysis, which is called confirmatory factor analysis. And by this technique, via structural equation modeling, we will learn how we can test some hypothesis that there are maybe 2 or 3 factors behind our data. So it will be our next step, I guess, in 2 or 3 weeks to recognize also confirmatory version of factor analysis. So here we have for brief recap, a basic picture how it works in EFA. So it means I have some manifest variables, or let's call it observed variables. We usually use squares or rectangles for these. For simplicity, by this picture, we have 4 manifest variables. So it means in my data set, I have some observed data. In our case, if I switch into our data file, which is called ISSP EFA, we have 11 variables that are ordinal scales. And we know, so we are slightly mischeating, that maybe there are 2 hidden dimensions behind, left and right, and liberal and conservative. But at least we have 11 variables that are all present in my data, and I will try to inquire whether there is something behind data, whether there is some hidden pattern, and that would be our goal. So it means we would be inquiring these factors behind, and the main logic is that we will try to estimate these links, or let's call these relationships. We call these links or its values as factor loadings or factor weights. In Czech also 2 expressions, faktorové zátěže nebo faktorové náboje se používá v češtině. And by these values, we would be able to interpret the meaning of factors. So let's imagine that these 2 are big and these 2 are small. So it means that this first factor is mainly based on first 2 items. And let's imagine that for red links, it would be that these 2 would be low, these 2 would be high. So it would mean that factor number 2 will be mainly created by item 3 and item 4. So here we are. And if I go back into our JAMOVI environment, so last time we tried to compute results of EFA. So if you remember well, the procedure can be found via analysis. And here there is a special menu which is called factor. And here we have exploratory factor analysis. And by this menu, you can ask to perform exploratory factor analysis. So first of all, you need to define set of your variables that are maybe somehow correlated. We also discussed that it would be nice maybe as the first step also to compute correlations between these variables. We skip this step, but if you would like to compute correlations, it would be easy. Go into analysis, regression, and correlation matrix would be the procedure for this step. So if I go back into EFA dialog, we can also check correlation between all these items by 2 tools. One of this is Bartlett's test of sphericity, And the second one is called as KMO, measure of sampling adequacy. And according to these values, here we have these two outputs. They are called simply as assumption checks. Here we have Bartlett's test of sphericity. Null hypothesis is saying that correlation between all of these variables is too weak, so there is no need to apply exploratory factor analysis. As p-value is low here, so we expect it would be useful, or it could be useful, to apply EFA. Then again, I would like to repeat basic warning related to this test. If your sample size is big, and big means at least 1,000 or even more cases, nearly in every case, you would get small p-value. So it means that nearly for all big data, you would get recommendation, apply EFA, in spite of the fact that maybe correlations are very, very weak. So that's why my recommendation is do not believe to Bartlett's test of sphericity if your sample size is bigger. Another story is to discuss about so-called KMO, or sometimes it is called as MSA, which stands for measure of sampling adequacy. And we can compute the value, which is based on the comparison of big varied correlations and partial correlations. And by some ratio, you would get the value in the range from 0 up to +1. And the simple rule is the bigger, the better. It means that if MSA or KMO is bigger, it means that variables are correlated more, and it means that your EFA would be more successful. So here, basic recommendation is saying, and you can go into the literature and find also some detailed recommendations, but the easiest recommendation is at least 0.5 for MSA, for KMO, and you can compute this KMO for all variables together. That's overall. So here we have 0.82. So it seems promising to apply EFA. And you can also apply computation of MSA for individual variables. In technical language, these values are called as anti-image correlations for these variables. So this is the meaning of these MSAs. And once again, 0.5 should be exceeded by these values, and it is valid for all these. So it means that also all individual variables should be included into EFA. So in other words, these individual MSAs is measuring whether individual variable is correlated at least to some other variables in dataset. So here it is fulfilled for all these variables, so we can go further. Okay, next one discussion, I hope so covered last time, was the discussion about number of factors, and we mainly relied on the default which is present here in JAMOVI, and also the same default option is followed in JASP, and this is discussed as so-called parallel analysis. So what is the meaning of this chart? So the first line, we call it in English a solid line. So it means this line with blue circles is the line of so-called eigenvalues. So these are some, I would call it descriptive statistics of our correlation matrix. And every time you must see pattern that these eigenvalues are decreasing and decreasing. If you sum up all eigenvalues for maximum number of factors, it must be true that this sum must be equal to number of original variables. So here if you have 11, sum of all these eigenvalues must be 11. So this is some description, these eigenvalues of the quality of individual factors. So the best is always the first factor. The second best is second factor, etc. And the weakest, I mean, in the explained variance is the last one. So it means here 11th factor. And this is the line for real data. And in parallel analysis invented by Horn in 60s, there was a recommendation. Try to generate data that are totally uncorrelated. or it means correlated only randomly sometimes. And this set of correlated data is here discussed as simulations. So here we have eigenvalues for uncorrelated data. So it means that these values are only slightly different from each other, so only slowly decreasing. And the recommendation based on parallel analysis is, let's try to take as many factors as there is this solid line above this dashed line. So it means blue points are above these orange points. And here, and we can see it very easily also inside this table with factor loadings, 3 dimensions are recommended. If you would like to choose another recommendation, so alternative recommendations are based on the shape of this so-called scree plot. So this is original plot of these eigenvalues for my real data. And recommendation is very simple. Let's try to take this shape and let's try to find something what we call usually in statistics as elbow. So here we have elbow. And recommendation, which is based on Kettle's reading of scree plot from 60s, is let's try to take one less factors than is present in the elbow. So here the recommendation would be to take only one factor for this data. So we have 2 totally different recommendations, 3 and 1. And here in this case, so it means for our data, we have also some, I would say, empirical recommendation that maybe we expect that our 11 items could create 2 dimensions. So it means something like left and right, and something like maybe liberal and conservatism scale. So these are 3 recommendations and 1 more recommendation, but usually not designed for this principal axis. Estimation technique is based on percentage of explained variance. So we could go into this factor statistics table, and here you can try to find cumulative percentage of explained variance, but here it is very small one, but once again, there is no simple recommendation for this principal axis technique, so I cannot offer very simple recommendation here. So here we are. And today, we should briefly discuss about further steps. So it means how we can very easily understand to this factor loadings table, and how we can understand to this rotation option. And then maybe we would like also to add some more step in EFA, but unfortunately they are not present in JAMOVI or CHESP, so I will tell you only something about the theory behind, but we wouldn't be able to perform these steps. First of all, I would like to ask for no rotation. So we should, as the first step, discuss about rotation tools and about possibilities to rotate our solution. So if we ask to perform EFA for the first time, we call it sometimes as primary or the first solution. So we would get one of infinite number of possible solutions that can be applied in currently 11 dimensions. So here we have the first possible solution with 3 factors. And if I rephrase it in geometrical meaning, so I'm taking original 11 dimensional space, and I am replacing this 11 dimensional space by 3 new axes by 3 dimensional space. So this is geometrical meaning of EFA. And as you can imagine, you can use 3 dimensions in very different settings, and there is infinite number of these solutions. And this is only one of these solutions, which is computed by principal axis. If you would change principal axis into different technique, here we have only 3 of these, minimum residuals, maximum likelihood, and principal axis. So for all these, you would get different solution from this, once again, infinite number of solutions. But only some of these solutions are useful for us. And if we go back to the discussion for us, according to the picture, the best solution would be to have quite big loadings only for some items and so for some factors to understand what is behind and to interpret the factors. So we try to find a solution which will ideally maximize or minimize these values of factor loadings. So that's why we usually take the first solution, which is applied by some of these estimation techniques, and then rotate to get, I would say, better results for easier interpretation. So that's the main goal of these rotations. So we try to change original solution into some, I would say, better solution. It means solution that can be interpreted easily. And first of all, I would like to say, if I go back to the presentation, that there are different types of these rotations. So here we have a discussion about rotations, slide number 20. And two big groups of rotation procedures are called orthogonal, and the second one is usually called as oblique rotation. So first of all, what does it mean? If I expect that my 2 or 3 or more factors are totally uncorrelated, then I would apply some of orthogonal rotations. Orthogonal means there is an angle which is 90, or in statistical meaning, it means these variables, factors behind, are totally uncorrelated. So if I compute correlation coefficient, it would be pure 0. I would say that this model of orthogonal rotation or uncorrelated factors is quite improbable to be followed in real data patterns. So mostly, at least in real data, I would expect that maybe these factors could be somehow correlated. So maybe, and this is usual general recommendation in current literature related to EFA, that the first step should be maybe based on oblique rotation. So it means that I would expect at least some correlation between factors. So this is more general application of this rotation to allow factors to be correlated each other. So this is general, and only, that's the recommendation in the literature, if you can recognize that correlations between factors are weak or nearly nothing, then you would apply in the second step orthogonal rotation. So that's the recommendation. So here we are, and first of all, I would like to show these results of rotations here. For maybe simplicity, I would recommend, first of all, that we would ask only for 2 factors here. So it would be easier for us to understand results. So I would go here into number of factors, and I would ask for fixed number, and I would ask for 2 factors only. So here we have 2 factors. And we would recognize also, I would say, big reason for rotation. If you apply mainly principal axis, and also if you would be using SPSS and you would be applying default in SPSS, which is so-called as principal components, this is quite common that the first factor is very strong one. So it means it is attaching nearly all items into the first factor, or first dimension. And the second one, third one, etc. are quite weak. So we discuss about this property as these techniques, once again, especially principal axis and principal components, is acquiring quite strong first common factor. And we would like, if I use totally non-statistical language, to destruct or to destroy this first common factor. And for this purpose, we need to apply rotation. So not only for easier interpretation, but also to avoid this solution that all items are related together into one factor or nearly all, I would ask for rotation. So that's all. And once again, we discussed that we have two options, oblique rotation, correlated factors, or orthogonal rotation, uncorrelated factors. So first of all, once again, according to classical recommendation from current literature, I would ask for some oblique rotation. So if you ask for rotation, here we have some procedures that can be applied. And I would mention only some of these procedures, as we do not need to go into details. So I would say that classical and the most common and sometimes also default in software packages for orthogonal rotation, so once again, for uncorrelated factors, is rotation, which is called varimax. In opposite way, I would like to say that I would say classical procedure for non-orthogonal or oblique rotation is called oblique. So these two only we will apply for simplicity. Then, if I remember well, Quantimax and Promax are also orthogonal, and Simplimax is oblique. So if I ask for the first time for oblique rotation, I would expect that I would destroy this first factor, and maybe that items will be distributed among these first factors, and maybe that I will recognize the pattern that some items will be related to the first factor, maybe I would call it as left and right, and maybe that some items will be related to second factor, and maybe I will recognize this is another scale which is behind the scene, which is liberal conservative. So let's ask for oblique, and let's see your results. And if I go back into my data only to see what is the meaning of individual variables, so here we are. So first 5 items, if I recap, government should redistribute incomes, owner of enterprise get rich, workers do not receive just portion of the earnings, exist one right for rich poor, and enterprise will afford cheat on employees. So these first 5 should be left and right according to their meaning. And then next 6 items would be liberal conservative scale, at least based on original ideas of those who invented this instrument and implemented it into ISSP survey. So if I go back into our analysis, so we can check it. So you can see quite big factor loadings for first 5 items. So it means it seems nearly ideal according to our expectation. So all these first 5 items seems to create something together. And once again, we know from the beginning that the meaning would be something like left and right scale measured by this instrument. I would maybe spend some more minutes by discussion of these factor loadings. So first of all, the meaning of these factor loadings, so it means statistics behind is that it is correlation coefficient for individual items and factor. So this is nothing more than classical Pearson correlation coefficient. So it means it could be as low as -1 and as big as +1. And we are mainly interpreting absolute values of these factor loadings. So it means it really doesn't matter whether there is plus or minus, but it really matters whether it is big or small one. You can see that here by this factor loadings tool, we are hiding loadings below 0.3 for easy reading. So it is much better for the interpretation. But once again, if you would like to publish this table with factor loadings, please avoid this hiding and every time show all these values. So it means also these that are below 0.3 or some other cutoffs. So that's the meaning. And here, if I would like to read these values, so you can see that the first value for the first item is 0.485, which is not a very big one, especially if you compare it to the second, third one, and maybe the first one. So this is the lowest correlation or the lowest factor loadings. And it means that if I would compare the importance of these individual items for left and right scale, this is the weakest one. So maybe if I would like to discuss whether some item could be omitted, maybe for further research, so maybe the first one could be omitted. It could be decision. If you would need to choose only 3 items, so maybe the second one, which could be omitted, is the 5th one, A47A 0.553, and then the rest, as we usually use a rule which is saying at least 3 items should be included, so the rest should be included. So that's only a simple recommendation here. And if you would like to choose all of these, it's possible. So at least these values are not very, very low. Let's go to the second factor. And you can see that for item, which is A47J, let's go to the meaning of this item. So this is item about censorship. Whether censorship is necessary for keeping the rules. So you can see that this loading is for both of these dimensions very low, at least below 0.3. And it means that maybe this item is useless for this EFA or for this construct, left and right, and liberal conservative. It doesn't mean that this item is not functioning all over the world, but as you have check data here, so it means that for check data, it's not working. So maybe if I would apply this instrument, I would omit this item for further research. That's my first recommendation. If you compare the level of these factor loadings and factor loadings for the first factor, you can see very easily that there is one quite strong item. It's A47H. So once again, what is the meaning behind death penalty for some crimes? So it is very strong. Sorry. Yeah, school should learn children recognize authority. Sorry for that. Yeah, you're definitely right. So this is the best item in the whole scale. And then you can see that all of these factor loadings are quite weak. You can see that also here for A47G, it was discussed that penalty case is even somewhere at the edge, 0.3 currently. So if I would ask for bigger hiding loadings cutoff, it would be totally out of this solution. So here I can conclude very easily. This is quite strong dimension, and I can apply all of these 5 items. For the second one, it is much weaker, and also some items are problematic. At least this item, once again, it was about censorship, if I remember well, and this one about death penalty. So these 2 maybe could be omitted. So if I would like to recompute solution and for further research to apply only 9 instead of 11 items, I would omit 2 of these items. So that's easy recommendation. And last one comment related to this table. As you can see, for such small table, too many words can be applied. So here we have something what is called uniqueness. What does it mean? And what is the meaning of these figures below uniqueness label? So all of these items, once again, according to our picture, so if I go back to EFA case, here we are. So all of these items are somehow explained by factors behind, as individual arrows for equations are going from factors to individual items. And here, this uniqueness, if you multiply this value by 100, is the percentage of unexplained variance by 2 factors that are behind my solution. So if I rephrase it by real values, 0.78.6, in percentages, it will be 78.6, would mean that approximately nearly 79% is unexplained for the first item, and only 21 percentages are explained for the first item. For the second one, you can see it's much better. 0.4 means that unexplained proportional variance is approximately 40, and explain is 60, etc., etc., etc. And you can go to some items that are problematic, and you can see that for nearly all items, for the second dimension, it is very poor explanation. For the first one, explanation approximately 21. Here, only 15. Here, this is the best, approximately 36. But here, it is just below 10%. Here, 11, and here, 16. So once again, we can see that at least some of items that are creating the second dimension are quite poor one. So once again, there are big doubts whether all of these 6 items should be implemented or whether liberal conservative scale can be measured by these 6 items, at least in the Czech environment. Once again, it doesn't mean that this instrument will not work in different countries or cultural contexts. But for Czech case, and I can show you also results for different application of this measurement tool in Czech, it's not working properly, at least in this part. So that's also possible usage of EFA, that you can discuss whether some measuring instrument is good and whether all items should be included. So we can also discuss about further research. So here it is, and as currently, once again, we are applying oblique rotation called oblique, it would be nice to see what could be correlation for these 2 dimensions, so for these 2 factors. Before we start, maybe we can try to make some estimates, some guesses. So I would like to ask you, not only those of you who are present here in the classroom, but also those connected via Zoom, to say, what's your expectation about correlation left and right scale and liberal conservative? So first question is, are these 2 dimensions correlated? And if yes, what's your expectation if liberal means more on the left or more on the right? So these 2 questions are closely related. So if somebody could help us to give us first estimate, it would be nice. And then we would try to resolve this puzzle by computation of correlation between factors. So some expectations? Correlated or uncorrelated? And if correlated, what would be the pattern of this correlation in Czech environment? So some guesses, especially for Zoom users, I would be happy if we would get some guess.
I think that in the Czech environment, the political right will be correlated with the liberal
okay, right, yes. Correlated to liberal, that's expectation. Okay, so thanks for your expectation. And now I would ask for additional output. And here we ask for so-called factor correlations. So we need to add 1 more table into our output. This output is useful only for this oblique rotation. So here we are. And I guess that this is the new output, which is called inter-factor correlations. And it is saying that the first dimension and the second dimension, fortunately, we have only 2 factors here, are somehow positively correlated. And the correlation, if I slightly round up, should be approximately 0.5. So at least it means that the correlation is not a very weak one. If you go back to classical recommendation from Cohen's well-known book about effect sizes, it is saying that correlations such as 0.1 are called weak one, correlation about 0.3 are called somewhere in the middle, and 0.5, something like strong correlations or big correlations. So it means, and once again, try to avoid this general recommendations, but currently it means that this big correlation, at least for social science case, is quite a big one. And if you go back to our previous discussion about expectation whether liberal would be more on the left or more on the right, we expect liberals to be more on the right. So for this explanation, I would need to go back into variables. So here we have original wording of questions. And if you go back into scales for answering individual variables, you can see that strongly agree is the lowest one, and strongly disagree is the biggest one on the scale. So it means that those who were agreeing with items were more on the left, and those who were disagreeing were on the right, and the same for liberal. Agreeing were conservative, and disagreeing were liberal people. So that's why if I go back to the interpretation of this value, it is confirmed what we expected. So it means the bigger inclination to left scale, bigger inclination to conservatism in Czech environment, and just opposite would be true. So it means more on the right scale, more on liberal scale or liberal conservative scale. I would like to say that if you would like to find similar patterns for other countries, they could be totally different. For example, let's take case of Germany, and I would expect just opposite correlation in Germany, as it is also somehow usually influenced by education behind. So that's only comment that this is not general pattern for all countries and all cultural contexts, but it is valid in the Czech Republic only currently, at least for last 30 years. So here we have a very, I would say, strong result, which is confirming that this type of rotation, so it means oblique rotation, should be applied. You can, of course, also apply orthogonal rotation, but once again, it wouldn't be the best decision here, but only to see how it works, we would apply this orthogonal rotation here. So I would ask for very max rotation once again. That's one of the most common. So if I would apply this very max rotation, I expect that results are not very different from previous one. But once again, previous solution was correct, as two dimensions are quite highly correlated. This is not the best one solution for my data, as here I expect that these two dimensions are uncorrelated, and that's not true. But you can see that by default, as you are forcing data to have two uncorrelated dimensions, table with inter-item factor correlation is saying, okay, that's zero. But that's the logic which is behind orthogonal rotation. So if you apply orthogonal rotation, every time factors will be totally uncorrelated. So this is not a proof that these two dimensions are uncorrelated, but this is only product of orthogonal rotation. So be careful of orthogonal rotation if your dimensions are not uncorrelated. So once again, basic recommendation, first of all, let's try to apply oblique rotation, and only if it's present here very low value for intermittent correlation, then maybe you can apply orthogonal rotation, as it would give you maybe more simple results in some cases. So that's about correlations and rotations. And the last one, discussion about it's impossible to apply this step directly in JAMOVI. So that's why I will open also at the end of today's session SPSS for some time, is saving of factors. Maybe, and it could be a result of EFA, that I would like to save results of these two dimensions. So it means instead of 11 original items, I would like to ask a software package to insert a factor number 1 and factor number 2. It means some estimation of their values into my data matrix. Unfortunately, and do not ask me why, in JAMOVI as well as in JASP, there is no such option. So as you can see here, there are quite few options here, and there is no saving icon. So there is no option to go directly into my data matrix and to add 2 new columns that would be discussing the level of left and right scale and the level on liberal conservatism scale. So once again, it's a pity, but it's not present here, but we would skip into a SPSS environment and I will show you how it works. It means generally EFA and also saving of these scores in SPSS environment. I would like only to add some notes to saving of these factors. So we call these values, or it is estimate of the value of factor as factor scores. So if I say that I'm applying factor scores, it means I am trying to estimate the value of the factor as the new variable in my dataset. By default, it means this is the logic behind EFA. Factor score is continuous variable. So it means ideally it would be from -infinity to +infinity. And mostly it would take values that would be standardized. So it means usually the average for factor scores would be 0. So it means it would be, in other words, centered variable. If for some variable the average is 0, so we call this variable as centered. We know about it from previous discussion about linear regression and centering of predictors. And mostly, at least for some common procedures for saving of factors, the logic is that it is also standardized by its standard deviation. So classical factor scores follow the rule that the average is 0 and standard deviation is number 1. So it is fully standardized variable, which is following this pattern. And if I say these 2 properties, and also factor scores usually approximately follow standardized normal distribution. So it means that, for example, 95% of all values are inside the range from -2 and +2, more precisely -1.96 and +1.96. And it also means that nearly all values will be covered by the range of -3 and +3. As you know, general rule that -3 and +3 standard deviation is covering approximately all values of standardized normally distributed data. So that's only application of this rule into factors. So first of all, I will only save these outputs from today's lecture. So here we are. And I would only close JAMOVI for some minutes, and I will open SPSS and data file for EFA. So I would need only to find the data, as I'm not sure where I saved this data file. So I guess that here it would be. SPFA and SPSS environment. And we would go briefly through dialogues for EFA and SPSS, and we would compare results and options. And I must say that for EFA, still SPSS is more capable than JASP and JAMOVI. Maybe that for future it would be slightly different. So here we have the data. We do not need to assign any missing values, etc. So it means data are prepared for analysis. So I would go directly into analyze. And here, if I would like to find EFA in SPSS, so there is a part which is called dimensional reduction. And here, there is only one option here, at least in a limited version of SPSS, which is called factor. So it means exploratory factor analysis. I would like only to mention that SPSS is capable only of exploratory factor analysis. If you would like to apply confirmatory factor analysis, you would need to choose another software package which is related to SPSS, which is called currently as ABM SPSS AMOS. If you go back to JASP or JAMOVI, there is also confirmatory factor analysis included in these packages. So here we are, and we can take all 11 items, so it means from government to strict penalty. Here it is. And here we can go through individual dialogues, as there are quite a lot of options here in SPSS environment related to EFA. So first of all, descriptives, and here we can ask at least for KMO and Bartlett's test. So if you would like to find these, you need to ask for these. This is the same style as in JAMOVI or CHESS. And if you would like to find also MSAs for individual variables, you need to ask for so-called anti-image correlation matrix. So here it's necessary also to add one more requirement. So that's for the first insight. And then we can go into extraction. And here you can see that by default, once again, and that's the mixture as we discussed last time, the default option is not direct exploratory factor analysis, but another technique which is called principal components. As we applied principal access, so I would ask also here for principal access as the general recommendation, at least for ordinal data, to apply this technique for first solution. And here we have quite limited options for decision about number of factors in SPSS environment. So the first option is based on eigenvalues. So this is the rule which is saying all eigenvalues above 1 will be applied. Then you can ask for fixed number. If you remember, these two were also present in JAMOVI. But in JAMOVI, there was one more option, which was based on parallel analysis. Unfortunately, parallel analysis is still not applied in SPSS. But you can ask also for script plot, at least for my original data. So you can apply Kettl's rule related to elbow in the shape of this script plot. So that's another option we can apply here. So that's extraction. And then we can ask for rotation. Automated option is none. And then you can ask for some other options. So we applied Varimax and direct complement. So it would be our second and the third solution in the next steps. So currently I would ask for none. And here we would go into scores in the last step to save factor scores. But now I would ask for options. And here there is very similar option to suppress small coefficients. In JAMOVI, it was called hiding some small coefficients. Here you can see that the default is 0.1. So if we ask for 0.3, it would be analogy to previous discussion of JAMOVI results. So if you click into continue and OK, so we can very simply find, I would say, same results as previously in JAMOVI. First of all, KMO or MSA is 0.818. If you remember well, it was the same figure in JAMOVI. And also a result of Bartlett's test of sphericity is the same. So that's very, very easy to understand. Here we have so-called anti-image matrix, or it is in plural, matrices. As the first one is covariance matrix. That's not very useful for us, but you would need to go to the second part, which is called anti-image correlation. And here on so-called main diagonal, here you can find small node upper index A. Here we have these MSAs for individual variables. So once again, we can recognize that for all of these variables, these MSAs are not very low. So we can use all of these variables according to MSA recommendation. So these are MSAs. And here we have, once again, the same table as previously, total variance explained. So in total, 3 dimensions here are describing 32. And here we have the script plot, the same plot as we discussed previously in JAMOVI. So once again, elbow is somewhere at the point of 2. So recommendation according to script plot would be only 2 dimensions. And then we have here the first solution, once again, quite big, first common factor, including nearly all of items. Once again, and it would be once again analogy to JAMOVI, if I would ask for only 2 factors, so I would go into factors extraction and I would type 2, I would get a solution which is the same as for previous discussion in JAMOVI. And once again, we would like to change this first solution by dividing items into 2 dimensions. And we know that we can ask for rotation. And once again, first one rotation would be oblique rotation. So once again, go into factor analysis, go into rotation, and oblique rotation, which is most common in SPSS environment, is called direct oblimin. There is only one more oblique rotation in SPSS environment, which is called Promax. According to direct oblimin on Promax, new one window for delta parameter or kappa parameter would be active. So for direct oblimin, you can see delta. And this delta is influencing the level of relationship or correlation between factors. My very simple recommendation is if you would like to have highly correlated dimensions, highly correlated factors, use this default 0. If you would like to find nearly uncorrelated dimensions, you should apply some big negative value. So that's easy recommendation for this delta parameter. And if I ask for this output, I would get a lot of new outputs currently. And here we have 2 tables. One is called pattern matrix and structure matrix. So for SPSS, you wouldn't get only one table describing our pattern structure, but structure of factors, but 2. And you would get also factor correlation matrix. And here, for delta parameter 0, it is saying that correlation between factors, so it would be slightly different from previous discussion in JAMOVI, I expect, is 0.336. So if we would somehow change the value of delta parameter, maybe we would be able to find the solution, which is default in JAMOVI. But still, it means that these 2 dimensions are quite correlated. So that's the proof. And here only we need to differentiate between so-called pattern matrix and structure matrix. So these 2 are slightly different as one of this table is offering correlation coefficients, and one of this table is offering regression coefficients. As for oblique rotation, these 2 are slightly different. My simple recommendation is that if you would like to follow the logic of original factor matrix, so it means it is correlation between factor and dimension, so you would need to go into pattern matrix. So if you are using SPSS for EFA and you would like to interpret individual factors, follow pattern matrix, and it will help you to find a solution. So that's about rotation and how it works in a SPSS environment. And last step, once again, if you go back into our presentation, is that we would like to save factors or factor scores into our data, and maybe and that's the main goal of the saving of factors, we would be happy if we could find also for these new 2 variables that will be present in my data, some relationship to some existing variables. So for simplicity, I included here also variable which is describing left-right scale, which is a direct question from the questionnaire. And also I assign here the variable distinguishing gender, male, female respondents. So in the next step, after saving factor scores, we will try also to find whether left-right scales measured indirectly is somehow correlated to left-right scales measured directly, and then maybe we can try to find whether male or female in the Czech Republic are more conservative or more liberal. So it would be our next analytical goal. So first of all, I would like to ask SPSS to fulfill these 2 columns by estimates of left-right and liberal conservative scale based on this 2-factor solution. And once again, from all previous discussions, we know that maybe some items should be omitted, but we would skip this omission. So we would use all of these 11 items. So if I like to have 2 new columns, 2 new dimensions, 2 factor scores, so I would go once again into factor analysis dialog. and I would need to visit the option which is called scores. Here, you can see that by default, no score saving is applied, but if I would like to apply, I would need to select save as variables, and SPSS enables 3 possible saving of vector scores solution. One is based on so-called regression technique. One was invented by Bartlett, and the last one by Anderson and Rubin. So these are names of statisticians, as you can understand. There are small differences between these algorithms. I wouldn't go into details. If you like, you can consult some technical literature about it. I would propose for simplicity to apply regression scores. They are quite nice. Once again, their property would be 0 is the mean, 1 is standard deviation. Usually distribution would be like normal scores. So I would apply for the saving of scores. So here it is. If you click into continue and OK, so we would find 2 new vector scores called as FAC11, FAC21. So the last number 1 is saying that this is the first application in EFA in my data set. And 1 and 2 for the first position is distinguishing the first and the second dimension. And you can also find that there is some description related to these variables, and it is called regression, as it is based on regression estimation of vector scores of the first vector for the first analysis and of the second vector for the first analysis. So that's quite nice to have these descriptions. And maybe if we would like to change it, we know that the first dimension is measuring left-right, and the second dimension is measuring mostly liberal conservative scale. And if we go back to previous discussion about individual scales for original variables, once again, government should redistribute incomes. Strongly agree is the lowest value, and for strongly disagree is the biggest value. So it means also that small values for this first vector score would be those who are on the left, and big values would be those who would be on the right side of left-right scale. And for liberal conservative, it will be nearly the same. Low values would mean conservative, and big values would mean somebody who is liberal. So that's only about the meaning of these scales. So it is following the logic of scales for original variables. And first of all, I would like to show you the properties of these vector scores. So I would propose that we would go into analyze, descriptive statistics, and exploration. And for simplicity, we will take these 2 variables. So it means left, right, and liberal conservative scale, which is created by estimation of vector score. And I would ask for plots only here. And if you go into plots, I would ask to see histogram, and I would cancel option for stem and leaf chart. And we can also ask for a box plot, or you can cancel it. That's your decision. I would only briefly comment histogram for this 2 variables. So here you can see a result for the first item. So you can see that mean is approximately 0 and standard deviation approximately 1, as I promised. And here you can see the picture. So it seems to me there is maybe slightly bigger proportion of people here on the left side of the scale. And here we have a similar picture for liberal conservative scale. Once again, maybe there is a bigger portion of people who are conservative here. So it's slightly asymmetric. But still, that's quite nice picture, according to my opinion. And now, once again, I would like to find some analytical results. So it means apply EFA result to some further analysis. So first of all, I would call it as validation of this new left-right scale. I would like to find correlation between left-right scale, which is measured indirectly, bi-factor score, and left-right scale, which is measured directly by the question whether I'm on the left or right. Before we would go further, I would only skip into this variable view window. And you can check that for left-right scale, there is no definition for missing values here, but maybe we should check our data as there is code 8 for I do not know. I cannot choose. So first of all, I would ask for frequency table. So analyze descriptive statistics frequencies. I would take left-right scale and check whether there are some I do not know, I cannot choose. And you can see there is 139 people. So before we would compute correlation, we should omit these people from the computation. So if I go back, I could go into variable view window and I would define missing for left-right scale as code 8. So currently, all variables are correctly prepared. So left-right scale directly measured, left-right scale indirectly measured, and we would expect that there would be some correlation at least. So I would go into analyze, correlate, bivariate correlation. So it means classical procedure in SPSS environment. First of all, I would take the first vector score and the second variable left-right scale directly measured. We can treat both variables as cardinal for simplicity. So correlation coefficient according to Pearson would be nice. Here we have some new parts of the dialog in SPSS 28 or maybe even in SPSS 27. So you can ask to show only the lower triangle. It is maybe better. And you can also ask not to show diagonal. So you would recognize only one correlation coefficient table. That's quite nice property, which was applied in SPSS. And here we have a very simple table for correlation. So at least there is some correlation, approximately 0.4. It is positive. So it means right by direct question are also right by indirect questions or indirect construct, and opposite is also true. But you can see that the correlation is not a perfect one. It's not close to one. It's quite small one, according at least into the first insight. And maybe the reason behind this that much better is to measure indirectly, left and right. And if you measure directly, as we discussed previously, this is quite imprecise measurement of left and right scale. So maybe the result I would treat as maybe the proof that it is much better to measure directly by some set of items instead of direct measurement by one question only. So that's only a short recommendation based on these correlations. And last one result that I would like to show is that we would be applying the second factor score. It means it would be discussing about liberal conservative scale. And for simplicity, we would be trying to find whether male or female are different on the average level on this scale measuring liberal conservative attitude. I must say that I am not aware of any big literature discussion about these differentiations. So maybe we do not have such big expectation that, for example, males should be liberal or female conservative or just opposite. So let's try only to find results. First of all, I would ask only for descriptive statistics. So the easiest would be to go into analyze, compare means and means. And here I would ask to compute means for second regression score. So it means last one item in my set of variables. And I would differentiate people by gender. So here it is. And if I apply this computation, I can see, I would say, nearly no difference at all. So you can see that for male as well as for female, the difference is approximately 0 if I round up. So it means that it seems that the level, at least for my sample size, of liberal conservative scale is nearly the same for male and female, at least for my sample data. And if you would like to infer this result to the whole population, so maybe the formal next step would be to apply two independent samples t-test. So once again, for recap, I would go into analyze for comparing means and for independent samples t-test. So here it is. Tested variable would be second regression score, and our grouping variable will be gender. First of all, we need only to know codes for male and female, 1 and 2. So I would ask for grouping variable defining groups 1 and 2. Click into continue. And there is one new option in SPSS 27 as well as SPSS 28, which is giving us estimates of effect sizes, Cohen's d, and also other effect sizes will be automatically computed for us. So click into OK, and here it is. So first of all, quite complicated table for independent samples t-test is including cleverness test for equality of variances. And as p-value here, it is called sig, is quite big one, we can continue first row as it seems that equal variances could be assumed. So that's the decision based on this cleverness test. And here you can see t-value, which is comparing the average from the first and the second group, is very close to 0. And it means, in other way, that it's expected there would be no difference detected by t-test. And you can find it very simply by significance column. I would propose to use two-sided p, and two-sided p is nearly 1. So it is very, very big value. If you set up alpha level at the beginning, something like 0.05 classical alpha level for statistical testing, it is much bigger, and there are no doubts we wouldn't reject null hypothesis. So it means maybe that the level of liberal conservatism scale average for male and female in the Czech population could be the same. It would be my conclusion. And if you would like to add some more comments, you would go into the new one table present in SPSS 27 or 28, which is discussing effect sizes. So it means these are some measurements of differences in some standardized units. The well-known is especially Cohen's d, but two alternatives very close, each hedge correction or class delta. And all of these could be found in a column which is called point estimate. Be careful, do not read the first column, which is only some technical standardizer. So do not take into account these values. Here is point estimate, and recommendation based on Cohen's book, once again, for Cohen's d is saying that if Cohen's d is approximately 0.2, there is small difference. 0.5 is discussed in Cohen's book as middle or middle size difference, and 0.8 or bigger is discussed as big difference. Here, this is nearly pure 0, so there is no difference measured by Cohen's d at all. Only for you to recap how we could compute this Cohen's d, it is based on the difference of these two means. So you would subtract this value for male and for female, and then you would need to compute a common standard deviation. So it means for both groups together, and you would standardize, that's why it is called standardizer here, 0.74, etc. So you would standardize this difference of means by the standardizer, and you would compute point estimates of Cohen's d. And for technical reasons, we can also estimate confidence interval for this Cohen's d, and you can see that also these values are very low. So it means there is expected to be nearly no difference between male and female on the average for conservative and liberal scale. So that's our final step in these discussions about EFA, and final step for application of factor scores for some further analysis. And as once again, these factor scores, so it means these two variables are variables that are cardinal. You can apply these as dependent, for example, these in t-test or regression, but you can apply also these variables as independent variables for further data analysis. So that's all about EFA and application of EFA for today.